The question we need to ask ourselves now is, what criteria can we use to compare languages? Some guys might get up and say, oh, how many lines does it take to do something? Or other types of parameters like that, or kind of benchmarks like that. But there has to be some other more general ways of evaluating a specific language and saying, oh, this is better as far as this issue is concerned, and that's better as far as issue is concerned. So what I would like to do now is start identifying which issues or criteria we can go and use for evaluating languages. So we got ourselves a whole bunch of criteria from the audience: efficiency of the compiler, readability, writability, documentation, cross-platform or portability, reliability, generality, simplicity, and orthogonality. So let's start talking about these ideas. So the first one I want to talk about is readability. And readability is the criteria of how easy is it to read the code. Now, that can include a lot of things, like, for example, overall simplicity. It's a manageable set of features and constructs, which means we don't have 1,000 things doing the same thing. Let's think of, for example, of a language that can have a lot of things, and it's like super huge, and you could do everything in 1,000 different ways. So you understand that it's becoming more difficult to manage, because you can have two different programmers, both programming language X, and one can't read the code of the other because he got used to this subset of the language, and that one got used to the other set of the subset of the language. So in a sense, we need overall simplicity, which is few features that repeat the same functionality, that everything is clear and well defined. Okay, we have what's called orthogonality, which means that a relatively small set of primitives can be combined in a relatively small number of ways. Let me give you an example of a non-orthogonal behavior. Suppose, again, C++, and we look at a piece of code that says cout ptr. That's my little piece of code. What will be outputted? What will be outputted? So the answer to the question, what will be the outputted, is dependent on what ptr is. And we're going to assume for a second it's a pointer and not some kind of integer or double or whatever. I'm going to assume it's a pointer, just like the name says. It's still, the answer can be very different. For all types, it's going to output some kind of address. For all types, except for one. If it's a string, this is of all types. If it's pointing to a string or a character sequence, right? If it's char star, so then it doesn't output an address. It outputs the string until it hits a null. Notice how the combination of two things behaved suddenly differently, right? If I took pointers and I combined it with the output operator, so I got a certain behavior. If I took a pointer of a specific kind and combined it with the output operator, I got a different behavior. Now it's obvious why they did it, but the point is, this is an example of lack of orthogonality, which means that we're not getting a small set of primitives combined in a small number of ways, and the combination all behaving in the same way. We're not getting that. We're getting something else. So this is a lack of orthogonality. It's done for a reason, and the reason can be legit, but that does not mean that it's a plus. So orthogonality normally makes things more readable. In the case that I'm showing on the blackboard right now, So in order for a programmer who sees this line to decide what's going to happen, he has to look in his history. He has to look up here. How is PTR defined? And then he would know how it behaved. Another criteria or sub criteria of readability will be control statements. The presence of well-known control statements, which everybody knows already of the C style control statements like for and while, all those. So if a language goes and implements it in the same way, the same even look and feel, so it's obviously more readable. Everybody would know what it means. But if you go and you have your own way of doing it, even though you're doing the same thing, but anybody who tries to read it is not going to be sure what you did there. So that makes it unreadable. The presence of adequate facilities for defining structures, all kind of other compositions and way of building things, it's got to be readable. It's got to be readable. So that's the criteria for readability. The converse, now it's not always exactly the converse, but many times it is the converse. We have writability. What is writability? Writability pretty much says how easy is it to express yourself? And again, we have simplicity and orthogonality, which means a few constructs and a small number of primitives and a small set of rules of how to combine them, and support for abstraction. If I can go and define complex structures and then abstract away the complexity, like we do in classes, like we do in all kind of in functions. Functions are, in a sense, abstractions. Instead of going and writing a Fourier transformation in order to do a square root, we just call the function square root. Notice we're abstracting away complexity. And that allows for writability. If I was not able to do that, so I can still accomplish the task, but it becomes tedious and unwritable. How can I express myself easily? Higher level expressions. Think of, for example, adding two numbers and storing them in a third number. And let's drop to a lower level language, for example, assembly. So you would load A and load B and then call add and then store it in C. While in a higher level language, you would just write C equals A plus B. Notice how easy is it to express what you want to express. So all these kind of things are, in a sense, part of writability. As an example, what would be the difference between a for and a while in a C-like language, which means like one of the C, I wouldn't say C or C++, it could be Java or C Sharp, but one of those that come from that type of family of programming languages. What would be the difference between a for and a while? So the answer to that question is that there is no real difference between a for and a while. Anything you can accomplish with a for, you can accomplish with a while. And anything you want to accomplish with a while, you can accomplish with a for. And again, I'm talking about specifically a C-based syntax languages. I don't mean all kind of other languages. There might be other languages, for example, where for really behaves differently than a while. For example, a for is supposed to be a counting loop, and a while is supposed to be a sentinel loop. Means that it just goes until some condition is met. A for is supposed to be a counting loop, like 1, 2, 3, 4, you count how many you want. You can increment by 2, increment by 7, makes no difference. But in the C syntax-based languages, there is no real difference between the two. You can write anything, you can write with a for, you can write with a while. Anything you can write with a while, you can write with a for. So where is the difference and why do we have two? And the answer to that is, in a sense, writability. You are getting, and readability. You are added, a for was added into the language to give you something that's more readable and more writable. Meaning if I look, for example, at some piece of code and I look at the for, now I write for, and over here we have our initialization, and over here we have our condition, and over here we have our increment, and then we have our code, that's down here, right? I could have written that with a while easily as well. I could have written it in some kind of a line of code, initialization code. Then I could have written the while and stuck in the condition. And then over here, I would have put my code. and then my increment. It would have been exactly the same, exactly the same. And I could do everything. I could do it without the increment. I could do without the initialization. I could do without the condition if I want, right? Just like I do with the while. So if I decide, for example, that I don't want initialization like in the while, I just wouldn't put anything here. I would just leave it blank. If I wouldn't want some increment, I would leave this blank. So in a sense, I can do everything with a for, I can do everything with a while. There's no real difference between them. At least in C syntax-based languages like C, C++, C sharp, and those kind of guys, there's no real difference between them. The idea is just readability and writability. It's a lot more readable. Take a look at the for loop. It's a lot more readable. When I look at the for loop and I see in one location all the parts of my loop, while if I talk about a while loop and I do it this way, it could be very, very difficult. Think you could have 1,000 lines between here and there, right? And the increment might not be at the last line of the while loop of the code. And therefore go find the increment. And therefore, for, in a sense, gives us I would say, syntactic sugar of how to get an incrementing loop written in a nice format. Now, when I say incrementing loop, I don't just mean a counting loop. For example, if you want to traverse a linked list from the head all the way to the tail, or all the way to the null at the end, right off the tail. The simple way to do it and the right way to do it would be using a for loop, right? You would say for initialization, your initialization code would look something like some PTR is equal to head, and your condition is as long as not PTR, as long as PTR, sorry, or star PTR, whatever it is, whatever you don't hit the null, as long as you didn't hit the null, and your increment will be PTR is equal to PTR arrow next. Now notice this is not an incrementing loop. There's no counter going on, but it's the same idea. We are putting in one location all the parts of my loop. It makes it a lot more readable than just a while loop that looks exactly the same on the right side, but has 1,000 lines of code to go figure out what's doing what. Right? So it has to be as long as PTR, right? Okay. So I'm saying, so this is a type of a language that provides this kind of capabilities, is a language, for example, that could be more writable or more readable. Now, a lot of times you say to yourself, oh, readability and writability are opposites of the same coin, which means if it's more writable, it's less readable. If I could do a lot using a little, then at the end go figure out what the poet meant when he wrote what he wrote, right? For example, the language Perl, and like it's very powerful, but it's impossible to read. So a lot of times it is one versus the other, but a lot of times it's not. A lot of times, for example, the for loop, it's more readable and more writable. So languages obviously make choices. And when they make those choices, we have to decide to evaluate based on the choices they made, whether we want to use that language or we rather not.